Hello everyone. So in this video I'm going to introduce another kind of differentiation which is called the multiplicative differentiation. So let's start with a very simple example. So consider $100 is deposited in a bank and you get $112 after 1 year. So what is the average amount increased per month for this situation? So we know that we can easily calculate by this formula. 112 minus 100 and over 12, which is $1. So we know that this is the average increase of the amount. So for the same situation, can we know how many times the money increases relative to the previous month? So we can calculate through the very simple equation. We multiply the $100 with k to the power of 12, which is equal to 112. So we want to solve for k. K to the power of 12 is equal to 112 over 100. And then we take the 112 power on both sides, which is like this. So let's have a look on the first principles of the two kinds of derivative. And we know the classic derivative from the Newtonian derivative, which is very famous. And how about the situation we encountered before? How about for the multiplicative derivative? So we want to have the ratio of the new values of the function over its original value, and then the whole ratio raised up to a power of 1 over h. So now we want the value of h to be as small as possible. So we take the limit and make h tends to 0. So this is the first principles of the multiplicative derivative. So we define the symbol of this multiplicative derivative by f star x, which is different from the classic f dash x. And we would like to have a look on the limit of this guy here. This format of limit reminds me of a very famous limit, which is the constant e. The e is the limit of n tends to infinity, the bracket 1 plus 1 over n to the power of n. If we replace n by another variable, which is 1 over m, and we know that m will be equals to 1 over n, we can change the limit to this form. We make m tends to 0, and then we substitute all the n by 1 over m, and then 1 over n will becomes 1 over m raised up to the power of 1 over m. So now their power are very similar. I would like to modify the thing inside the bracket now. There is a 1 plus inside the bracket, right? So now I change the limit. I put a 1 plus here, and then I copy the ratio. But in order to make the expression balance, where I need to minus 1 here, and then raise up to the power of 1 over h. So let's have a closer look. It's limit h tends to infinity. 1 plus. Okay, so let's make it to become a single fraction. Minus fx, and then over fx. And then raise up to the power of 1 over h, right? And then let's have a look on this guy. So this guy, when h tends to 0, so the f bracket x plus h this guy will becomes fh. So the whole expression over fx will tends to 0 when h tends to 0, right? Because this guy becomes 0, and then in the numerator is the difference of 2fx, which is 0. So now the criteria is the same as the constant e here, because this guy will tends to 0 also. So now we would like to make the power to be the same as the red box here. So now I modify the limit a bit. And I copy this guy over fx. Okay. So now notice that the power is the reciprocal of the thing behind 1 plus. So I intentionally write the reciprocal of this guy in the power. So I will put, okay, I will make a line here, fx over fx plus h minus fx. So if I write like this, so I erase the thing above, I need to make the things balance. So I will multiply the same denominator here and then over. So now I will put the h here. So I will use a red pen here, and then I will multiply the 1 over fx here. So all the things are balanced now. So what happens? Notice that this guy is very familiar. We know that it is f dash x, right? So the whole expression in the red box here will become the constant e, and then this yellow box will become f dash multiplied by 1 over fx. So the whole limit will becomes e to the power of f dash x multiplied by 1 over fx. And this is very familiar. We can write it as the derivative of ln fx. So now we know that the multiplicative differentiation is valid for the function only positive defined. So now we derived the formula for f star x, which is equal to e raised up to the power of the derivative of ln fx. And I hope that you guys will enjoy this video, and if you like to watch more about this kind of differentiation, please leave a comment below, and I will see you in the next video. Bye bye.